Last week we worked on calculating bacon numbers, and we did that both in Excel and in Python. And what I hope you took away from last week's videos and also from last week's exercises is that the tool you use influences what solution you can come up with. If you're working in Excel, then typically you think in terms of cells and references between cells. And if you have to work with lists in Excel, you have to use array formulas. And it's possible, but it's harder, and this limits the way you can think. Whereas if you solve the same problem in Python, it gets a lot easier because lists are first-class citizens. You can just take any range in the spreadsheet and put it into a list immediately. And if you want to do some sort of operation on your list, like a minimum, you just have to use minus and the list that you want to work on. You don't have to fiddle with array formulas. So because you're using Python, it's easier to work with lists because they are built in Python and you don't have to go through a lot of trouble. And exactly this idea holds in many cases. So if you use the wrong tool for the job, then it's not only less efficient to hammer a screw in, it's not just that it gets harder, it also limits your imagination. If you always build stuff with a hammer, then probably you're never going to come up with the Delft tool connection, because this is a connection where you connect wood without using any nails, so you don't need a hammer. And if you're always grabbing for the hammer first, you will never come up with this solution. And this exact same idea holds in data problems. If you always sit down at your spreadsheet immediately, there are some sort of solutions that you're just never going to come up with because they don't fit in the spreadsheet paradigm. And that's what this week's videos are all about. Maybe we were using the wrong tool all along. So let me show you another tool to use using a fresh new example. What you see here is a map of the Netherlands. This is where we are in Delft. Suppose I want to take the train from Delft to Groningen. That's here. So there's no direct train, and we can see this on the map because the trains are the black lines on the map. And there's no direct train from Delft to Groningen. So how am I going to make this travel? I have two different options. Either I take the train to Leiden, that's here, or I take the train to Rotterdam, that's there. And from there, I can take a direct train to Groningen. So either I go this way, or I go that way. And if I want to calculate what the best option is, I also need to add weight to my arrows. So this one, from Delft to Leiden, will take me 21 minutes. From Delft to Rotterdam will take me 12. And then from Rotterdam to Groningen is 2 hours and 39 minutes, and this one is 2 hours and 28 minutes. So I can calculate my total travel time by summing these two and summing those two. And for this representation, I don't even need the map anymore. If I have my graph, my lines and my nodes with all the numbers attached, I can just delete the whole map. There we go. And this is now a correct representation of my problems. I have a node, Leiden, Rotterdam, Delft, and Groningen. And I have arrows between them, this one, that one, and those two. And those arrows have weights. And this is called a graph, a representation of a problem in terms of nodes and arrows. And of course, you have imagined that we can use this same scenario, the same method, to analyze our bacon problem. Let's have a look at the bacon problem, how it looks like in a spreadsheet. We have actors and movies, and actors that have played in movies. And I can draw this problem like a graph too, like I did with the map of the Netherlands. I can say, here is Kevin Bacon, and he has played in the movie Crazy Stupid Love. I just draw a line between the actor and the movie. And I can repeat this. I can add Emma Stone and Julianne Moore because they have played in Crazy Stupid Love too. And I can continue this process and make an entire graph of the problem that we are analyzing, who has played in which movie. And because we are representing it like a graph, you see that immediately your view on the problem changes, because it gets really easy now to calculate the Bacon distance from Bacon to another actor because we can just traverse the lines in the graph. And that's what we're going to explore in the next video. Now that we have a problem in the form of a graph, we can also start to use different tools. So we don't need generic tools anymore. A spreadsheet or Python are like a Swiss Army knife. They can do anything you want. You can use them for budgeting or planning or for doing a Bacon-like problem. But now we can use a very specialized tool for graphs, very much like the tongs you use to eat snails. They're very, very useful if you're eating snails, but they're pretty useless for eating anything else, like eating pasta or eating rice. They are very specialized tools. And this is also what the graph tool is about. And the graph tool that we are going to use is called Neo4J. And this is a graph database. The word already says it, is really used to store and analyze graphs. So if you download Neo4J, this is a freely available tool. You can just download it for many different platforms. And if you do that, and if you start it, this is what you will see. Just this little box. What do we do? So the first thing that we have to do is select a folder on our file system where we're going to save the database. Just an empty folder, no magic. You just select a folder and you hit start. And this is what you get, the green box with a link. And if you click it, you'll be taken to your web browser. Just a normal browser like Firefox or Chrome. We'll start your normal browser and you will see this. That's it, this is Neo4J. So it's not immediately clear what you have to do here. First, let's start with get our Bacon data into the database. So we go back to our spreadsheet and we have to save our spreadsheet as a CSV file, a comma-separated value file. This is a format that Neo4J and many other tools can easily read. Maybe you've done this before. You just click Save and you select the location where you want to save your CSV file. You enter a file name and then from the drop-down list, the Save As one, you select CSV. There we go, comma-separated value. Oh, we have a dot too many. We remove the dot and we click Save. And now we've saved only this worksheet can we save as a CSV. So Excel warns us, it says, I can only save one worksheet and you lose pivot tables. We know that, we're okay with it. We want to save it as a CSV file. So what we have now, if we open the CSV file, is this. This is how the CSV file looks like if you open it with Notepad or any other text editor. You have a first line that is the first column of the spreadsheet, in this case movie, and then you get one line for all of the lines in the spreadsheet, and columns are separated, of course, with a comma, because it's a comma-separated value format. So we have this data. Now we have to get this data into Neo4J. So let's go back to Neo4J, get our CSV file, there it is. And what we cannot do is just select the data and put it in. We cannot just copy paste. We have to use a special command called load CSV. So we type that into Neo4J, load CSV from the location where I have just saved the CSV file. And then for every line in the CSV file, we're going to perform a certain operation. So here's the location of the CSV file, and we're going to open it as row. And this means that we are going to iterate over the spreadsheet, over the CSV file, and every line is called row. And this is very much like the for loop in Python, where we have an iterator I that first has the value 1, and then 2, and then 3. This is also what happens to the row. So what are we going to do? For each of the rows, we're going to create something that is a movie. We will create a movie, and the name of the movie is row.movie. That's the first column, in this case the only column of our CSV file. So we can run this by hitting the play button, and then Neo4J says, okay, I have created 4 nodes. We don't really know yet what has happened, but something has happened because we have created 4 nodes. So what we can do now is get the nodes out. And I'm not going to explain the entire syntax of this language. This language is called Cypher, by the way. I'm just going to show you a few things that you need to know for this example, but we will put links online to background material where you can learn all about Cypher. So how are we going to get the nodes out? There's a special command called match, and that means looking for all the nodes. So in this case, we say we match just a node n, any type of node, and return that to us. And now we see the 4 notes that we have entered into the database. We see they are movies and they have the labels that were in the CSV file. And we can change the layout a little bit. We can say that the labels need to be the name of the movie, and we can play with the size of the notes. So now it's easier to see that we indeed have the 4 movies in our Neo4j database that were in our CSV file. They're right there. And what you also see is that this is a tool that's made for graphs. If I just say, give me everything that's in the database, the neutral, the normal form is not a list as you would get in a normal database. No, it are these little dots, the notes in our database. And this shows us that we're really working with a graph database here, something that's optimized for thinking about notes. Now what we also need to do in addition to the movies is get the actors in, and we can again use the load CSV command for that. And now we're not creating a movie, we are creating an actor, and we do that really by saying create an actor. We're not going to add a label, this is a type actor. No, we really say create an actor. And this sounds a little bit cryptic maybe, but let me show you how that looks like if I show you all the notes. Initially, all of them look gray, and you see that indeed some are an actor and some are a movie. But what we can do is, again, we can play with the layout. We can say we want movies to be green, and then you see all the movie notes are now green. And we can do the same for actors. Let's say we want actors to be pink. And now you can see that we really have 2 different types of notes in our database, movies and actors. So of course, the next step that we need to perform, now we have the movies and the actors in our database, is make the connection. So again, we have saved the 3rd worksheet of our spreadsheet as a CSV file where we now have 2 columns, one that's called full name and one that is called movie. And again, we're using the match command now. First, we load the CSV files. We know this by now as a row from the CSV file, but we're going to match each column, the first item with an actor and the second item with a movie, and this is how that looks like. So we say match. Yes, we say match. There it is, we say match. We are going to match, and A is an actor. And what are we going to match it with? Well, the name, the full name of the actor has to be equal to the name that is in the row of our CSV file. So that's also called full name. So in the first case, the actor that we're going to make a connection for first is Kevin Bacon with the movie Crazy Stupid Love. So this first match line is going to search for the actor in the first line. And the second match that I'm making now is saying I'm matching movie, and the name of the movie has to be equal to the movie column in my CSV file, the second column after the comma. So what these first 2 things do is find an actor and find a movie. So if I have those 2, what I need to do is make a connection between them. And I do that with a create, just as I said, create an actor and create a movie. I'm now creating a link from A, the actor, to the movie, and I'm giving the connection a name. I'm naming it acted, so A acted in M, Kevin Bacon acted in Crazy Stupid Love. And if I execute this create, then again, Neo says, yeah, okay, I have created a bunch of relations. So let's have a look at how it actually is visualized. If I just use the same show me all notes, then I get a graph instantaneously. So if I just put my data in and I say to Neo4j, give me the data, this is what I get. It's immediately visualized as a graph, and you can see, of course, we know this by now, Kevin Bacon has played in Crazy Stupid Love with Julianne Moore. It's all right there, and it very much looks like the picture that we had in the previous video that we were drawing on the spreadsheet. We get a graph immediately. So we're almost there. We have the right representation now, but now, of course, we still want to perform the calculation of the Bacon number. So let me show you how that goes if you use Neo4j. So what we want to do is calculate a path through the graph, a number of steps, like we did Delft, Rotterdam, Groningen, and now we want to have Kevin Bacon, Julianne Moore. So we're matching again, we're looking in the database, but now we're not looking for one node, we're looking for a path through the node from an actor with the name Kevin Bacon to another actor with no specific name, we don't know the name. And how does the path have to look like? Well, it has to be 2 hops. An actor, a movie, another actor. And what do we want to return? If we have found such a path from Kevin Bacon to another actor, we would like to have the name of the other actor. And if we execute this, indeed, we get all the actors that have a Bacon number of 2 that are 1 hop away, or in this visualization, 2 hops away from Kevin Bacon. We can do the same thing for everyone who has Bacon number 3, because then we need 4 hops. It works. It's that easy to do it with Neo4j. The only problem that we have here is that Scarlett Johansson occurs twice because there are 2 ways that we can reach her from Kevin Bacon, and we can solve this with a very similar construct that we have used all the way back in the pivot table video, the distinct. And if we add that, then we get only 2 actors with a Bacon number of 3. So you see, it's just 1 line, and then we get everyone with Bacon number 2, everyone with Bacon number 3, which is already pretty amazing. But we can do better than that. We can calculate all Bacon numbers of everyone with just 1 line of cipher code. So what we're going to do is we're going to say, give me the shortest path. And this shortest path is not a function that I have defined. This is just a built-in function in Cypher. So we're going to say, give me the shortest path from the node that matches Kevin Bacon. We've seen that in the previous queries as well. And what I want is only the star. So not 2 steps or 4 steps or 100 steps. Any number of steps, we don't care. That's what the little star indicates. And what we want to have in return is, again, the name of the actor. And what we also want, because we have named this path P, the length of the path. Ta-da! And now indeed we get Kevin Bacon has 0 because the path from him to him is 0. And people with Bacon number 2 have 2 hops, and with Bacon number 3 have 4 hops. So we're almost there. We only want Kevin Bacon to have 1 and all the others to have 2 steps as 1 step. So if we divide it by 2 and add 1, we have all Bacon numbers for everyone. Doesn't matter how long the path is, in only 1 line of cipher. Isn't that cool? Remember that last week we needed like 25 array formulas for all of the actors, and we still needed 25 lines of Python, and here we can do it in just 1 line of cipher. So don't get me wrong, this is not a Neo4j advertisement. I'm not saying that Neo4j is better than Python or is better than Excel. For some problems that are really graphy, Neo4j is a very good solution. But like the tongs for a snail, it's very specific. You can't use it for planning or budgeting. It's for one specific tool only. So what I hope you take away from this week and previous week videos is that sometimes you shouldn't run to your spreadsheet immediately. Of course, in the first 6 weeks, I showed you everything there is to know about spreadsheets, and you can do many, many things with them. But sometimes it's also a very good strategy just step away from the spreadsheet. Don't go to your computer. First think about the problem, go to the whiteboard, and sometimes you can use a tool that's very suited for a small part of your problem better. So if you ever need to calculate a Bacon number, now you know that Neo4j or another graph database might be a better solution than a spreadsheet.